All right, welcome back. So phase 4 is going to see us setting up the game manager, which also reinforces that resolution setting we were talking about earlier. Now the idea here is the game manager is actually the brains, the central processing section of our game. All the different features that we're gonna build, the ball, the paddle, the bricks, all the scoring, the UI, the way we manage how we jump from level to level, right? Start to level 1 to end and then back around. All those different settings, all the different buttons and whatnot, all the logic that drives us from level to level automatically, winning and losing, that's all going to be hosted right there inside the game manager. So we're going to, as this project continues to grow, we're going to add more and more functionality to that specific class. So what we're talking about now is this phase 4. So because we only need one game manager out there ever, right? We don't want two brains in our system. That might actually cause some really bizarre issues. What we want to do is use a design pattern which makes a single object, a single class, the only one ever in existence. And if it spots any others, it basically plays by Highlander rules, right? It destroys. It destroys the others. There can be only one. And so the idea here is the design pattern we're going to use is called a singleton. So if you look that up, there's all kinds of information on it. But we see singletons pop up as managers every so often in projects, games, that kind of stuff, because you only want one central point that's capable of storing information and being talked to. So you don't want other ones out there. So we're going to make a singleton, but in order to make the singleton function properly, we've actually got a couple of edge cases that we have to deal with. So if you recall, if we go back out to the Unity execution order graphic, Unity execution order, right, there we go. If you go back to the execution order, what you'll notice is that if we go scrolling down, right up here in our initialization section, right? Initialization, the editor initializes, then some more gameplay objects. We've only thus far seen start, and then down here, just scrolling down a little bit, we have update down here at the bottom. We're going to start employing several more of these bubbles to provide more and more functionality. But right up here at the top, we have awake. This is the very first thing that happens on your game object, which means if you had something like the ball and the paddle and a brick and the game manager, and let's say your ball or your paddle started up and they tried to talk to the game manager, but the game manager didn't yet exist, what would happen is your code would generate an exception. You'd get a null reference exception because the timing just didn't work out, right? Your code was trying to talk to something that didn't yet exist. So in order to allow that object to actually exist so that those other systems can talk to it, we want to move its creation time, its initialization time, earlier than those other objects. So while ball, brick, and paddle can use start normally, we actually need to make the game manager employ awake. That way it starts up earlier. So in order to do all that stuff, I want to jump back over here to Unity, and we want to, here inside the hierarchy, create an empty game object. So right click, create empty. And in this particular case, because I've not moved that debug camera, again, this is a new project, we get it automatically right here at origin. Now, if yours isn't, if yours is maybe moved around in the scene somewhere, right? You don't have to do this. I'm just demonstrating. All right, if it's been moved around and you have different values, this usually happens. I'm going to delete this real quick. You don't have to. If you move the debug camera around, the second you create a new entry, or a new empty game object, or any other object for that matter, notice the transform is already changed because Unity is thinking you probably want that new object right there in front of the camera. So it goes straight down the camera, this debug camera we're looking through, it goes straight down its Z, a certain number of units out there, and then creates your object. Well, doing this, if I kind of orbit, if I kind of fly around this scene, this can make organizing your level very Interesting, because you start building hierarchies based on offsets, and we do not want that. Again, if you have a specific reason to put an object somewhere in your scene, great, do that. But pretty much mostly all of our objects, most of them, when we're creating them, we want them at origin. So in order to put this guy at origin, you can either manually type in 000 or just hit that gear and say reset. And now it puts it back over here at origin. Okay, see it right there. And by the way, I'm using the right mouse button to give myself this flying capability, and then also using the WASD for forward, back, left, and right, strafing left and right, and then Q and E can go up and down. So you can use those to navigate around, and holding shift goes much faster. Okay, so this game object right here, we actually want to name it. We go into rename mode. We actually want to name it Game Space Manager. And what I'm doing here with the space is because you see with all these other Unity objects, Unity objects here, we tend to use spaces up here in our hierarchy. We don't necessarily tend to use spaces down here, especially if it's a type, if it's a class. We're not allowed to use spaces. Only underscores are allowed. So that kind of brings us to our next item is we need a script to drive this game manager. So if we come over here to add component, we can add a component. And this item, I'm actually going to name it slightly different than most of our objects out there, right? Normally you have the words all kind of squished together, and we're using Pascal case. But in this case, instead of just saying game manager, instead of doing that, I'm going to use an underscore between the E and the M, because I'll show you what happens in just a second. Just go with me on this. Create game underscore manager. Say it's a new script. Go ahead and create and add it. So when Unity finishes compiling, it will be attached to your game object. And down here in your project, let's take that game underscore manager file and let's move it into our scripts folder. Again, stay organized. And to see it, we want to hit that little disclosure triangle. That delay you just saw was because when you move files, it triggers a recompile. So it kind of pauses the ability to work with it. Now, the reason I chose to use an underscore here is because, for whatever reason, if you do not do this, I'm just demonstrating what can happen. If I get rid of that underscore in the file name, Unity, for whatever reason, changes the icon to this little gear. And I frequently get the question, did I just break something? Am I interfering with some other system? No, you're not. It's just for whatever reason they did this. There are other aspects, like if you name something tile or folder, it'll actually take on the persona of an actual folder. This can make things very confusing, so please try not to do that. So I'm gonna undo that change that I just made, put my underscore back into file name, which again triggers a recompile. Okay, so our game manager now has that. So game space manager now has game underscore manager, the script attached. Now, I'm going to write some code in here, but I'd like to turn this game manager into a prefab for future use. So I'm going to click and drag game space manager down onto my prefabs folder, and when I release it, it will turn into a prefab down here, and this item up here will turn blue. So if you look really closely, the letters are all blue now. And it also gives us open, select, and overrides. This is the thing that really changed with 2018.3, this new prefab workflow. So realize that if you click select, it will pick the prefab asset down here in your projects. Remember, these are assets on your disk, on your physical hard drive. These are prefab instances that live inside your scene. So select can take us back down to the asset. If we go back up to the instance, you'll also notice there's this little tiny right chevron here. If you click on that, that takes us into the prefab itself. We're in prefab mode at this point, and this allows us to edit basically this guy down here, kind of the root object for all your other scenes. if you happen to find yourself, I'm going to click back into my level. If you click on the prefab up here, you can also click open to get to that same spot. I'm going to go back into the level. And then if you're in your game manager down here, your asset, your prefab asset, you can double click it to go into it, or you can also click this open prefab. And any changes you make in here will propagate to your instances as long as you don't have an override. So you can create yourself like a single brick or a tree or some unique thing and then just drag copies of it into your levels. And then if you decide later on you want to change all of them, you can make changes to your prefab asset, and as long as your instance doesn't have an override, a unique modification, those changes from the asset will be seen in every one of the instances. So kind of a neat way. Again, double check the documentation in the slides and the instruction document. There's more information on exactly what you can do with prefabs. It's pretty nice. So now that I've made some changes and I'm about to start making some edits to code, I want to go ahead and save this scene just in case Unity decides to crash. And now I want to go over here to my game_manager and double click that to open up Visual Studio. And again, I'm using Visual Studio 2019. You're perfectly fine to use 2017 or 2019 Enterprise Community. Really doesn't matter which one you're using. Just as long as you're seeing, once your project loads up, you see attached to Unity. That's kind of the telltale sign that the two programs are properly talking to each other. So now here inside this file, I want to make a few modifications. So number one, I want to change start to be awake. And now this comment right above it is no longer really correct, so I'm going to triple click this line. You can also just drag and select it. Triple clicking will select the whole line and just delete. Now, awake, because it happens early, it happens at the very beginning, when the object very first starts to get created in your level, comes alive. The idea is we could potentially have multiple game managers out there. And the way a singleton works is, again, it plays by Highlander rules. If it detects others, it will destroy them. So what we want to do is hold on to this specific game manager. And if anybody else pops up later on, we can compare. Are they the same as this? And because they'd be two different instances, that question would answer no. They are two different instances. So we can destroy the other, the imposter. So in order to hold on to this information, what we need to do is create a property to basically create a variable to hold on to this value, but I also want to be able to access it through other systems. So I want to turn it into a property, right? Elevate its status to a different kind of variable, a field up here at the top. So just as before, we have our fields. We will come back to the fields later on when we're talking about scoring and that kind of stuff, our UI and score functionality. But we also want to drop down and create our properties section. And the first property we need, number one, it's got to be public, so the outside world can see it, so that all of our other three classes can talk to it. And we want to share it. We want to make this variable shared across all. Basically, anybody can ask the game manager for it, and it will always return its one single self. It only remembers itself. So in order to do that, we need to use the keyword static. This keyword moves this variable, this property we're about to create, it moves it from an instance level, right? We would have to create a new game manager, and then we could access the new game manager. But in this case, we can access it directly from the game manager class. So it moves it from an instance level to a class level. So we talked about properties earlier, and that the next item is what is the type, right? Is an integer, a float, a bool, that kind of stuff. In this case, the type is actually this class. So game_manager. And in order to tell everybody out there when they try to talk to this field, this property, that it is indeed the instance of the game manager, we want to call it instance. And again, we're using public, so we want to use Pascal case, capital I instance. And then a property has the curly brackets right after that, and we need our getter and setter. Now, we want anybody out there, ball, brick, paddle, what have you, to be able to get this instance, to be able to talk to the game manager. So we can just say get semicolon. But we only ever want awake here inside the game manager to set it to itself. We don't want anybody else out there to be able to say, oh, game manager.instance, you now equals something else, because that could cause all kinds of issues with our gameplay. So it would basically destabilize the engine, the core brain of the game. So what we want to do is we want a setter, but isolate it to this class. So to isolate your functionality, you use private and set semicolon. So now, in order to make use of this instance, which is a link to this game manager, we want to, down here inside awake, we want to ask the question, well, if this is the very first time we're starting up, we're waking up, we won't actually have a value here. Instance will be null. So we can do a quick check inside awake if instance is equal to null. And if it is equal to null, then we know that this is the very first game manager instance that this project has seen. So we want to remember it. So instance, remember it's a game manager, and we talked about the this keyword being able to say that that is this class. Well, if we're trying to remember ourselves, we can say equals this semicolon. So it remembers this copy of the game manager. Now, when we transition from scene to scene inside Unity, everything that's currently in your level, your current scene, is destroyed. And we do not want the game manager to be destroyed. Remember, it's the brain. As we move from level to level, we're going to hold on to stuff like our scoring information, and we want everybody else to still be able to talk to it. So we can customize this one instance. So in order to tell Unity that we do not want this specific game object, the game space manager, we don't want it to be destroyed, we need to tell the engine to don't destroy it. And it turns out Unity has a method called don't destroy on load, and it takes in an object. Which thing do we not want to destroy? Well, remember, this talks about this class. Game object lowercase g talks about this game object. So we can send it lowercase g game object, and that will preserve this specific game manager. In practice, when we start running, what you'll notice is the game manager that's currently sitting inside our start scene will, our level 1 scene, or whichever scene we're in, will actually transition down to a unique scene called Don't Destroy on Load. It will no longer be part of the current scene that we created it in. So the other approach here inside Awake is that if instance does have a value, that means instance will be something and it will not be null. So we need to do a quick check. If instance is somebody else, if it doesn't equal this, then we know we've got an imposter. We've got a clone out there somewhere. We've got another game manager that we need to destroy. So right after that if, it's closing curly bracket, we need to say else if, because if we have some information, this if will fail, and we else, but then also if the instance does not equal this, right? It's somebody else, then inside its body, we need to destroy it. So destroy, just like don't destroy on load, Unity provides us a destroy method. And what object we want to destroy is that other game object, whoever it is. So game object. And now, if this is the case, if we've just destroyed this object, we don't want it to potentially carry on doing more functionality here inside update. We just want to leave. And the way we leave is by using the return keyword. So if it's somebody else, we tell the engine to destroy it. That takes like a frame to actually happen, but then we just leave. No more functionality would happen. But if this is the first time, we remember ourselves right here. We tell the engine, don't destroy us when we transition to other levels, other scenes. But then we want to reinforce those resolution values we talked about, that 4x multiplier. So down here at the bottom, right after the else if, I want to drop down a couple of lines. And I said that we want to multiply it by 4, but who knows? We might want to change that in the future to some other scaling factor. So I'm going to say, let's hold on to that scale inside of a variable for possible later use. So we can say int scale and set that equal to 4. Now we can make use of scale, and in order to tell Unity programmatically how to change its resolution, that actually, since you're talking to the screen, right, the display, you actually want to talk to the screen class. So this is capital S screen. And off of this class, we have a method. If you go looking through these options, there's a lot of neat things you can fiddle with, but the method we're looking for is called set resolution. And if you look at its method signatures, you'll find there's 4 of them, and they take different arguments depending on what you want to try to do. So the one we want to use is going to take in a new width, and we said that was 224 times 4, but here, since we're using scale, let's use that, scale. Since we're using that variable, we need the height, so we're using comma, space. The height is going to be 256 times 4, but we're using that scale variable, scale. And since we told the player settings earlier that we didn't want them to be in full screen and we didn't want that resolution picker dialog to allow them to change anything, we also want to inform the system here for full screen that no, indeed, we do not want full screen. So false and semicolon. Now, it is worth noting that because this game is going to make use of Unity's physics engine a little bit more than most normal games, the default is actually a little slower than the real-time, 60 frames per second or whatever update. So it turns out if we, let's go ahead and, just in case, let's go ahead and save this file. So Control S, and again, you see a little asterisk up here. That indicates you've not saved this file yet. So Control S. I'm going to jump back over to Unity. That's going to compile in the bottom right corner. And when it finishes, if we jump up to the Edit, Project Settings, and take a look down here at the bottom, we have Time. Well, it turns out that since most default games, they might not necessarily use, at any given level, it might not necessarily use the physics engine that much. So Unity kind of tones it down a little bit. This 0.02 is actually 1/50th of a second. So if you divide 1 divided by 50, you'll get 0.02. Well, because we're using physics, we want to turn that number up just a little bit more. We'll actually get much more accurate bouncing and collision detection, as well as just the game will seem to play a little bit better. So it turns out, instead of 1/50th of a second, if we turn this up a little bit to 1/75th of a second, it means the physics engine calculates just a little bit faster. It gets a little bit more accurate. So I could change it right here. I could type in, the number is, let's see, the number is 1/75th is actually 0.013 repeating. But remember, this setting is also part of the project settings and won't carry over, just like our Arkanoid item right here. So instead of changing it right here in this project setting, I actually want, because I want that setting to be in my test project as well, I want to change it in code. So if I go back over to my Visual Studio, right after we dealt with the set resolution, I'm going to make a little note here to myself that this is actually, so project settings, time, and fixed time step this is fixed time steps default, which is 0.02, which is equal to 1 divided by 50. We want to crank that number up just a little bit. So if we talk directly to time, we can actually tell the fixed delta time, whoops, sorry about that, fixed delta time to be some other number. Well, what number? 1 divided by 75f, to keep that floating point component. And this, well, it'll be faster and more accurate. Okay? So with these modifications, this will make the game manager a singleton. Now, as we continue building up the game, we're gonna actually build up a couple more levels, start and end, and as we go between those levels, we want to be able to transition based on button presses. We're going to actually push a button in those two scenes to go places, like you saw in the demo earlier. But then we also, just as a quick hack, as a while we're play testing the game, before we have the scoring system and the floor to send us to win or lose, we want a quick little kind of cheat code. And we're going to make use of update for that. But in order to use update to activate the cheat code, we need the code to actually drive the functionality. So down after update, I want to make a section called, this is like a comment to illustrate that we have specific functionality in this section. So in screaming caps, I'm going to say this is my scene management related stuff. So scene management. And drop down a couple of lines. So in here, I want a method that my buttons can call. The buttons will be set up in the UI over in the editor, but the functionality is going to live right here. So in order to be able to call them, the method has to be public, can't return anything, and we have to give it a name. So load scene, and we need to tell it what scene to load, so we're going to send in a string called scene, give that a body, and inside this bit of code, we need to talk to the scene manager. The scene manager is the thing that's responsible for loading scenes, telling us about scenes that were loaded, holding on to information about scenes themselves, not just the management side of them, but the scene object itself. And so in order to talk to scene management, or scene, see how, notice the tooltip, or the autocomplete is a lowercase scene down there at the bottom. That's our string, that's our parameter. I want to talk to capital S scene, or scene manager, but you'll notice it's not coming up in this listing. This file has no idea what this item is, and that's fine. It lives somewhere else. We need to bring that piece of information in. So if you click off of it or hit escape, and now mouse over scene or scene manager, whatever you typed in a second ago, use the show potential fixes. And in this listing, what you're going to see is we can bring in the entire namespace with this first line, or we can say only bring in this one line right here. Now, we'll use this technique in just a second, but what we want to do is this using. Use the using directive to import the entire chunk of functionality that lives inside the engine, inside this namespace, scene management. So if you click on that, what you'll notice is scene manager will go teal. But if you scroll all the way up here to the top, line number 4 was automatically added to our code using Unity Engine dot scene management. So that brings in all the functionality that the scene management system provides to us. So the scene manager, the scene object, and so on and so forth. So coming back down here to scene manager has a method called, so we do our dot, called load scene, similar to the one we just wrote, and it takes in, there are 6 different versions. One that will take in an integer, and we'll come back to that shortly. We'll actually use this for automated level work here in just a second. But the next version down uses a string, and we just provided it a string called scene. So send in scene. Close off that method and add your semicolon. Now, since the buttons, there are two of them, one will let you play or play again, and the other will quit and basically turn off the editor, right? Stop the editor from playing. If you're in the editor, that behavior's there. If you're in a build, then the editor doesn't exist. So there's a rule in Unity, you're not allowed to have editor code inside a build. It's not allowed. Well, if I want my application, my build to quit, then I need to call out to some specific code to perform that operation. So if we drop down after our load scene, we're going to create one more method. This will be for quitting the game. So we said public, so the outside world can see it, those buttons can see it. Void, it's not going to return anything. And quit game, parentheses, we're not sending it anything. Its sole purpose is to just quit the game or tell the editor to stop playing. This, in a build, we need to tell the actual application to stop running. So if you type in application.quit, which is a method, so parentheses, this will stop a build, an executable, from running. This has no effect inside the editor whatsoever. This is straight from the documentation on this method. But inside the editor, what I want to do is mimic that behavior. So just real quick, I'm going to jump back over here to Unity. When I'm playing, right, I press the play button, we start playing the game. If I want to quit my game, it would be the same as clicking the play button to stop the editor. So I want to do that same behavior. So back over here in our code, what I need to do is, remember, editor code cannot exist inside a build of your game. So if we tried to add some code to tell the editor to do something, and we tried to build our game, we would get an error. We simply wouldn't be able to compile. So the idea is Unity looks at every one of its platforms, Windows, Mac, Linux, PS, insert number, Xbox, insert number, as individual unique platforms. And the code for each one of those things can change. Unity also looks at the editor itself as a platform. And so if you try to build here inside the editor, you'll have a flag, a kind of a variable out there that says this is the editor. If you try to make a build for any of those other platforms we were just talking about, you won't necessarily have that flag. And so you can use that to compile your code depending on the platform. And it turns out, if you go out to Google, or rather, I have this in the notes right here. We're talking about save scene and quit game. If you click on this editor right here, you'll notice this link, platform dependent compilation. We are compiling depending on the platform. If you go out to that link, the idea is we can take advantage of this is playing right over here. And this is playing link, you'll notice, according to the documentation, this lives, right? So editor application, so not application.quit, but editor application.isPlaying. This is a property, so we can access it, so no parentheses here at the end. And here's a little demo of how you can make use of it. But notice it uses, right here, using Unity Editor. So this line of code, as well as these lines of code where we see editor application, I have to protect the build from that kind of editor code. And that means if I make use of this platform-dependent compilation, I can actually tell the compiler to remove the code when it sees that we're building for a platform that's not the editor. So if you go looking down through here, what you're going to see is a bunch of capital words. All these words, they have to be capitalized. If they're not, then the system won't work. But basically, we know about, are we talking to the editor in general? Are we talking to the version on Windows or Mac OS or so on and so forth? And so if you scroll down, the takeaway here is that if you scroll down to the bottom, there's a snippet of demo code. And so this demo code, if, very similar to our normal ifs, right? We're going to ask the question, do we see Unity Editor? And if we do, we can log out, hey, we're in the editor. This if is a little special. You'll notice this pound right in front of it. We programmers call this pound, not a hashtag. But pound if triggers basically a kind of pre-process. Before the compiler really starts to chew on the code, it sees these things. And it says, oh, I can perform an if conditional. If Unity Editor is defined elsewhere, then I can basically leave this code alone. If Unity Editor doesn't exist, this code will not be part of the thing that the compiler looks at. It's kind of final output. So you don't even have to worry about it. Calling editor code simply won't be there. The system will automatically remove it. And because this is kind of in C#, it's technically part of the editor, but because it kind of happens before, sorry, not the editor, the compiler. But because it's before the compiler really kicks into gear, the idea is we have to also tell it when to stop that if statement. So we have an end if right after that. So if something, end if. So we want to make use of this kind of code to basically turn off that code if we're outside of the editor. If we're in the editor, then we can use it. So in order to plug those two pieces of information together, what we want to do is over here in our code, right after we've dealt with our quit, I hit enter a couple of times to give myself kind of a little space there. That documentation, in case you're following along with the images, I'm going to keep this right here commented out so our line numbers all line up. What I want to say is pound if space Unity underscore editor. And then right after that, I need to turn off that if. So pound end if. And between those two lines, I'm going to add, I need to talk to the Unity editor. So because that does not exist, if I scroll all the way up here to the top, because it doesn't exist inside the Unity engine, and if you remember back just a second ago, this link to is playing, it showed using Unity Editor. Well, if I did that using Unity Editor right up here at the top, I'd also have to use a pound if Unity Editor. And that gets a little overkill. I don't want to necessarily clutter up this area up here at the top just for that one feature. So it turns out, instead of saying using and then all of this stuff, I can actually just specifically say where the thing lives. So if we go back down to our code down here, I know this editor application lives inside the Unity Editor namespace. So instead of using, I can use just the namespace itself directly. Unity Editor, see how the autocomplete is suggesting? Oh, right, namespace, Unity Editor. Dot, and I have a bunch of different things that I can talk to. So, I mean, I encourage you to look at some of these bits of functionality so you have an idea of what's in the system. But we're talking to the editor application dot is playing, and we want to set that equal to false, semicolon. Now this will effectively stop the editor from playing so long as we're in the editor. But this code won't exist if we're making a build. So pretty neat little trick to allow the system to work. Okay, so now double check that you've not got any errors in your Visual Studio. If you have the error list, making sure there's nothing there. Also, when you save this, if you jump back over to Unity and let it compile, you shouldn't see any errors or warnings. If you are, pause the video and figure out what happened, because it can cascade from here. Errors can cascade from here. So you want to just make doubly sure that everything is good on that front. So now, going back to the instructions, in phase 4, we've talked about these different items, right? The singleton, we've created our load scene, our quit game, we've added the editor functionality. This allows us to move through phase 5 uninterrupted. We don't have to jump back and forth as we're constructing things. Now, I said earlier that we want to be able to have like a little cheat code to allow us to jump through our levels. So the idea here is if you're in level 1 and you're still building the game, you don't necessarily have your win-lose functionality. So we just want to verify that our start, level 1, end, back to start, to level 1, to end. We want to make sure that functionality works, and then the quit buttons as well. So in order to do that, we want to jump back over to our code and scroll back up to update. Now here inside update, what I want to do is make use of that load scene method right here to artificially say, based on a key press, to go to the end scene. If I go to start and I press play, I'll be sent to level 1. But I have no way of leaving level 1. So if I press, in this case I'm going to use the escape key. If I press the escape key, I'll be sent to the end scene. That way I can verify this functionality right here actually works. So in order to use this code, I also remember that this is like a cheat code, and I don't want this to be live in the final version of the game. So what I'm going to do is I'm going to make a little to-do. It's kind of like a sticky note. It reminds me to come back later on. Now, Visual Studio has a neat little feature that if you go take a look at Tools, Options, and right here under Environment, about almost all the way down at the bottom, there's Task List. And in this task list, you'll see there are certain words in here, these tokens that are watched for by the editor itself. Hack, to do, undone, and so on. You can even add your own if you want to. But to do is going to let us add something in here that's monitored by the editor. Now it turns out, if you go up to View, and about halfway down the page is Task List. And if you click on that, you'll get this little window down here that is where, if you type to do in your code, it will list right here. So I'm going to pin this for just a second so you can see what happens. But inside my update, since this is going to be code that I want to disable later on once I have the actual gameplay functionality working, I want to come through here and say, as a comment, those tokens are part of comments, I want to say to do, colon, and notice it popped up in my list down here, and now I need to actually give it some information. So this, I'm going to say disable once verified. And later on, as I'm working on the rest of my code, I'm going to put some more of these to-dos in here as we get to spots where we don't yet have code, but we know this will be a great place to do something. We can make a little to-do note to ourselves, and later on we can come back through here, and if you double-click this, each of these items that will be listed, it will take you directly to that spot so you can fix or finish the code that you've been writing. So now that we know how this thing works, I'm going to unpin the task list window, that little pop-up thing, and continue with this code here inside update. So I said I want to watch for the escape key to be pressed. So that's if input dot get key down, and inside the parentheses, what key are we looking for? Well, that's going to be key code dot escape. So if we press escape here inside the body, what we want to do is call our method load scene down here. So load scene. And what scene do we want to go to? Well, we want to go to end. And if you decide for whatever reason to change your scenes names later on when we go to save those, you'll want to change this. Otherwise, you'll get an error. It'll try to go to end, won't find an end, and it'll tell you that right there in the console. Hey, I cannot find this particular level. Okay, so now let's go ahead and save this code and jump back over to Unity and let Unity compile. And so jumping back to the phase 4 document, now that we've added this debugging code, we can basically move on to phase 5. Now we'll continue with phase 5 in the next video. So please just double check that you've got all those those bits of code, as well as no errors or warnings popping up down here in your console. Also, double check that your items here, these are buttons, they're like toggles, they're filters for information. If they're all pressed, right, they have this like lighter gray versus this dark gray, these will filter errors and warnings and information. So just double check that those are depressed so you can see the actual information the editor is trying to tell you. So with that, I'm going to stop this video and we'll continue on in the next one.